Today we're going to be talking about multiplying and dividing rational expressions. When we're multiplying and dividing rational expressions, what we need to consider is anything that we would normally do with fractions, we'll do the same thing with rationals. So when we add fractions, we have to have a common denominator. When we multiply fractions, we do not. Those same rules that apply to fractions apply to rational equations as well. So we're multiplying today, so when multiplying, we do not have to worry about having common denominators. We're going to first start with multiplication and division that does not require any factoring or canceling before that, but that's what we will move on to later on, tomorrow as a matter of fact, but today we're just going to be multiplying and dividing just simple fractions, simple rationals, excuse me. This is the first example you should see on your Delta Math, and it's a division by two monomials. What we've got to consider when we're doing these is before we do anything, we need to recognize if we have any excluded values. This happens anytime that we have a denominator with a variable in it. So we do have a denominator with a variable in it, so in this case what we have to do is identify where it is that this variable will be equal to 0. So what we do is we set the denominator. We set that denominator equal to 0. We actually set it to not equal 0 because when we equal 0 we have an error because you cannot divide by 0. Now anytime you don't have a plus or minus sign, that excluded value, that restriction on the domain, is going to be 0. So if we divided by 5, this would be 0 divided by 5, which of course is 0. And then when we take the cube root of 0, we will obviously have 0 again. So we have an excluded value of 0. Now when we have division, we have an interesting situation because we have to find that excluded value twice before we keep change flip and then again after. So I kind of alluded to what we're going to do next. We never want to divide rational expressions. What we're going to do instead is little phrase you've probably heard back in Algebra 1, if not sooner, is we are going to keep, change, flip. So when we say keep, what we're talking about is keeping the first expression exactly the way it was. Next thing we're going to do is the change, and the change refers to changing division to multiplication. And then the flip refers to the second expression here, which is 5x to third power over 6. And that is our flip in our expression keep, change, flip. So now, and you probably remember from geometry, a lot of times the teachers would have said multiply times the reciprocal. It is all the same process. As long as we keep those things organized and taken care of, we should be fine. Now at this point, I'm going to show you two methods in which we can do these, and you choose the one that you like the best. I personally like to cancel. Now you can cancel any part of the numerator with any part of the denominator as long as they have a common factor, kind of like we have with 4 and 6. 4 and 6 are both even numbers, so I can factor out a 2 from each, leaving me with a 2 and a 3. And then I can also do the same with the 5 and the 5. So what I've done is I have simplified before multiplying. So my numerator ends up being 2 times 1, 2, x to the first times x to the third, which is x to the fourth. And my denominator will be 1 times 3, which is 3. The advantage to this is it's a little bit faster. We've got to write a little bit less. The disadvantage is it does become sometimes a mess. And if you were to make a mistake, it's a lot harder to find your mistake than the alternative method. Now make sure you understand this is an alternative method. Don't ever do it both directions. It doesn't make sense. The alternative is to do this. 5 times 4 is 20. X times x to the third, which is x to the fourth. And then my denominator is 6 times 5, which is 30. And now I reduce. So it doesn't matter if you multiply and then reduce, or reduce and then multiply. Just as long as you take care of this process, the 20 divided by 30 is 2/3, and then x to the 4th is exactly the same. So this is the first example that you do see on your Delta Math, and again, notice that regardless of the method you choose, this is how it works. You need to find the one that works best for you and the one you're most comfortable with. Second example that you shall see on your Delta Math is this one. Notice we are multiplying, and we have a negative number. Now, this is going to be true only for this topic. With Delta Math, it is important that you recognize this. The negative sign needs to be moved to the numerator. That is not a math rule. That is just a Delta Math software. I won't even call it a glitch. That's just how they programmed it. So when you get to this answer, make sure you always put the negative in front of the numerator. An actual math, though, you could put it in 4 places. You could put it in the numerator, you could put it in the denominator, you could put it in front, and then your 4th option, you could put it in the top and the bottom. That is the only way that you can mess it up, is to put it in the top and the bottom. So make sure you do not. Of the 4 ways, 3 of them are right. This is right. The way that it's written is right. This is right. The only way that's wrong is to either forget the negative sign completely or to write it this way. Don't ever give it to both the numerator and the denominator. But for Delta Math purposes, and this is the way I do it anyway, I put the numerator in the negative in the numerator, and for Delta Math, that's just the way you're going to have to do it. I can also solve a number of mistakes that students make with one simple thing, but I'm going to show you one of the more common mistakes I see. People coming in and marking out 2x and 2x like they are like terms. Well, 2x and 2x are like terms, but this is not 2x. This is 2x plus 3. And remember the phrase we talked about last week, if you cannot factor it out, you cannot cancel out. So I cannot factor out a 2x from this denominator, so therefore I cannot factor it out. Here's a simple way of keeping from making that mistake, a simple parentheses. Simple parentheses there is going to keep you from making a lot of mistakes. Now, at this point, all we need to recognize on multiplication is numerator times numerator, denominator times denominator. You can do this work in your head, but for today's purposes, I'm going to show every step. So it would be -4 times 2, and then the denominator would be 9 times 2x plus 3. Now, I haven't canceled anything, but I'm about to make a mistake. Before I do cancel anything, I've got to make sure that I establish my restrictions on my domain. In other words, what makes my denominator equal to 0. So the value that we cannot use is -3/2. That will not show up on your Delta Math, but that is a skill that we definitely need to know. Now we multiply. -4 times 8 is, or -4 times 2 is -8x, and then we will distribute the 9 into our parentheses. And this is the simplest form. -8x over 18x plus 27. This one looks more confusing than most. We're down to our division, which means we are going to keep change flip. And again, this looks very intimidating, and it really is just the way that it's set up. So let's change the setup. This is the same thing as saying x minus 6 divided by 2x divided by -6/7. So before I do anything, what I want to do is take my excluded value. So I have a denominator here. I need to make sure that this denominator does not equal 0. Since it does not have a plus or minus sign, that is 0. So I cannot use 0 for this entire equation. But since this is division, we don't want to work on division. What we want to do is we want to multiply times the reciprocal. So we will take x minus 6 over 2x, keep, change division to multiplication, and then flip our second one. And for delta math purposes, we are going to move the negative sign up to the top. We also need to drop some parentheses here. This will keep us from making mistakes. So just try to get in the habit of doing that. And then from there, it's just top times top, bottom times bottom. So I end up with negative 6x times x minus 6 all over 2x times 6. Once we have our distribution of our negative 7, be very careful that you do distribute a negative 7. We end up with this over 12x. So just be prepared for the fractions written in fraction form. This is essentially a fraction divided by a fraction. And then your final example, to math, is another division. We have to take the excluded values of the denominator before and after we flip it. So in this case, the 9, it's impossible for 9 to become 0 by plugging in an x, so we have no excluded value there. But when we keep, change, flip this thing, keep, change, flip. Now from the resulting keep, change, flip, we have just created a new denominator. So we need to make sure that that new denominator that we just created does not become 0. And what you'll soon learn is it's the opposite of the b value over the a value. So we would have 2x plus 3 unable to become 0 when we subtract the 3 and divide by 2. So we get x is not equal to negative 3/2. That is our excluded value. But for the top, what we're going to do, drop some parentheses to keep us from making that mistake. And it is just numerator times numerator, denominator times denominator. So 4 times 9 is 36. 5 times 2 is 10. X. 5 times 3 is 15. So that's what we would have. This was the fourth example on your delta math. What you'll later see is that I brought up some old factoring stuff because tomorrow we're going to move into factoring before multiplying. We definitely want to do that because if we can cancel things before we multiply, it makes the problem that much easier. So you'll have 2 examples like that. Do not try to turn it into a keep, change, flip. Always try to simplify as much as you can before you do that. All right, have a good day.